Hi everyone and welcome to the video on cubic functions in their stationary point form. What I'm going to do now, the start of this video is just about getting the basic shape of the cubic graph. So what I would like you to do is to complete the table of values that you can see on the screen at the moment and then plot the points out so that you can get the graph. Okay. So what I'm going to ask you to do is just to pause the video and then I'll start up in a few more seconds with the solution. Alright, so pause the video now. Okay, so to do the solution, well, we know that y equals x cubed, so negative 3 cubed means negative 3 times negative 3 times negative 3, which is negative 27. Now I can fill the rest of these out fairly quickly. They're all quite nice. So we go through the point 0, 0. I need the y-axis to go up to 27, so what I'm going to do is make it go up by 3's. So 3, 6, 9, 12, 15, 18, 21, 24, 27. And neg 3, neg 6, neg 9, neg 12, neg 15, neg 18, neg 21, neg 24, and then neg 27. So when x equals 1, y equals 1, that gives us a point pretty close to the axis, and it'll be the same out this side. Okay, when x equals 2, y equals 8, so that's going to be about here. When x is negative 2, y is negative 8, which is about there. And then when x equals 3, y is 27, which gives us this point up here. When x is negative 3, we have a y value of negative 27, so down here. So to draw this, we make a nice smooth curve through these points. And up this way as well. And there we have it. This is what the graph of y equals x cubed, or f of x equals x cubed, looks like. This graph has an important point. So this point right here is called a point of inflection. Now this is actually a stationary point of inflection, which means that at that point the gradient of the curve is 0. So it's a little bit like with quadratic equations, how we have maximum and minimum points. They are also stationary points because they have a gradient of 0. So the graph goes completely flat just in that instant. And yeah, what it actually means if it's a point of inflection is that the gradient on one side of it has the same direction as the gradient on the other. So we can see that on the left-hand side of this point right here, so out here, the graph has a positive gradient because it's increasing. And we can see that out to the right-hand side, out here, the graph also has a positive gradient. Whereas if we consider like maximum or minimum points, a maximum point is this point right here. So on the left-hand side of it, the gradient is positive, but then on the right-hand side, the gradient is negative. And similar for a minimum point, okay? So to the left of a minimum point, we have a negative gradient, and then to the right of a minimum point, we have a positive gradient. So anyway, that's what makes it a stationary point. And I refer to this form, the f of x equals a at the front of x minus h all cubed plus k, as the stationary point form, because it enables us to simply read the transformations off the equation and then create the graph based on that. So we have this stationary point form, and it will always have the stationary point with these coordinates. Okay? So let's have a quick look at a couple of questions. We'll just sketch them out, see how they go. To begin with, nice one, f of x equals x cubed plus 5. Now, hopefully from your understanding of the quadratic equations, you'll recognize that this works in exactly the same way. So when we have a plus 5 on the end of the equation, what that does is it translates the graph 5 units upwards, or to be really formal about it, 5 units in the positive direction of the y-axis. So it's going to be this shape moved up 5 units. So to sketch that out, just draw my axes. And then we know that it's going to have the stationary point there. It's gone up 5 units. And I know it needs to have this shape. Now we could also calculate the X intercept because clearly we have one. So if I do that, we make, I should say, f of x equals 0. That means 0 equals x cubed plus 5. So we can take away 5 on both sides. And then we can take the cube root of both sides. Now this is a little bit different to the square root, right? Because when we did quadratics, if you took the square root of -5, you would have said that there's no solution. That's because it's an even root. Okay, so when we have an odd root, like a cube root or a fifth root or anything like that, we can actually take those roots of negative numbers. Okay, and so I'm just going to label this point here as the cube root of -5. And, well, there we have it. Now, you can use your calculator as well to convert that to a decimal value if you want to, but, you know, I would say that it's probably not really all that necessary. Because the main thing is I haven't put a scale on the axes anyway, so it doesn't really matter. Now, let's have a look at the second one, okay? The second one's slightly more complicated. So, when we have something in the brackets with the x, that is the horizontal translation part of it. So this is going to translate the graph 2 units to the left, or I should say 2 units in the negative direction of the x-axis. I'm just going to summarize the changes here. So we're going 2 units to the left. This part here is moving the graph vertically, so it's going to translate it 1 unit down or 1 unit in the negative direction of the y-axis. We also have this negative out the front here. Now when we put the negative out the front of something, what it does is it reflects the graph in the x-axis. If we reflect this graph here in the x-axis, it just turns the graph upside down. And so I know that the shape of this is going to be like that. And now I can sketch it. So, probably should also label this f of x. We go 2 units to the left, 1, 2, and 1 unit down, and that's where our point of inflection is going to be. And we could, you know, quite easily calculate, say, a y-intercept or an x-intercept. So, y-intercept we make x equals 0. F of 0 equals -0 plus 2 cubed minus 1. Now, 2 cubed is 8, so it's -8 minus 1, which is -9. 2, 3, 4, 5, 6, 7, 8. It's going to actually be just down there. And if I want to calculate the x-intercept, we make f of x equals 0. So 0 equals -x plus 2 cubed minus 1. What I'm going to do is I'm going to add x plus 2 cubed to both sides. Then I'll take the cube root of both sides. Now the cube root of -1 is just -1, because -1 times -1 times -1 equals -1. And then I need to take away 2 to get x equals -3. So at least that's a really nice solution, right? And, oh, what's just happened there? All good, managed to fix it. So, just because of the symmetry, or this, we can know that the graph is going to pass through there as well. And now I'll draw it, so it's going to be a nice smooth curve like this. And there we have it. The last one is looking a little bit different. So when we have a negative like this, where the negative is appearing just in front of the x, like it's inside the brackets there, this is a reflection in the y-axis. Okay, and so because it's a reflection in the y-axis, that also makes the graph, now if we consider this one up here, imagine that being flipped in the y-axis. It's going to go sort of like that. Okay, so I know that it's going to have that shape there. I know that it's going to be moved 6 units up. And in this instance, it's going to be moved 4 to the right. Now, we can figure out what that horizontal translation is just by taking the part in brackets. So the 4 minus x, and putting it equal to 0. And then if we rearrange that, we can add x to both sides to get x equals 4, which means that it's 4 to the right. Okay? If it was negative 4, it would mean 4 to the left. So now I'm going to draw this shape. This one here I don't think is going to work out as nicely as the last one. So we need to go 4 to the right and up 6. So there's our point of inflection. And I could calculate Y intercept. So f of 0 equals 4 minus 0 cubed plus 6. Now that's 4 cubed, which is 64 plus 6, which means 70. Our y-intercept is going to be quite a long way up here. Okay? And the x-intercept, we make f of x equals 0. So 0 equals 4 minus x cubed plus 6. Taking away 6 on both sides gives us 4 minus x cubed equals negative 6. Taking the cube root gives 4 minus x equals the cube root of negative 6. And then taking away 4 leaves us negative x. You know, rather than taking away 4, what I might do is add x, and I'll take away the cube root of negative 6. So 4 minus cube root of negative 6 equals x. Now you could use a calculator to get a decimal approximation there, and I might actually just do that. So, set to decimal down here. 4 minus the cube root. To get the cube root, it's under math 2, I believe. Oh, no, maybe I missed it. There it is, sorry. Cube root of negative 6. Oops, I don't want the complex. It's 5.82. So if that's 5 and that's 6, it's going to be about here. And so now I can just draw, oops, a nice cubic graph like that. And there we have it. I should label this here, and I probably should label it with coordinates as well. So, you know, it's 4 minus the cube root of negative 6 comma 0. But yeah, that's about it really. These can be done on your calculator. So if I write the equation y equals 4 minus x to the power of 3 plus 6, then I can bring up the graph, highlight this and drag it onto the axes. And I'll change my window so that I can see it all. So I'm going to make my x min negative 10, max 10, y min negative 100 perhaps, and max 100. There we have it. and we can see some information about it. So if I go root to get the X intercept, it's 5.82, as we said. If I want to know the coordinates of the point of inflection, I just go to inflection here, and that's 4, 6. And if I want to know the y-intercept, just go to y-intercept there, and that is at 70. So there we have it. Anyway guys, I'll leave it there. See you next time.